All right, Gio. Uh, Second example of section 7.5 underway. First of all, I'm going to go over this part. It's on the top, or it's right above this example. We've got a triangle ABC with lengths 3, 4, and 5. We have a triangle DEF with lengths 6, 8, and 10. And our task is to find out the similarity ratio, the perimeter ratio, and the area ratio. So the similarity ratio can be found simply by doing the proportions like we've been doing. So we can do leg AB over leg DE as long as they're corresponding, and any of those ratios will give us the similarity ratio, because it says in our statement, very important that it says this right above the triangles in your drawing. It says ABC is related to DEF. So since it says that, we can use proportions to find the similarity ratio, and if we do any of the proportions of the corresponding legs, like 5 over 10, that's AB over DE, 5 over 10 will give us 1/2, so the similarity ratio is simply going to be 1/2, and the perimeter ratio is going to be found pretty similarly, except we're going to add up all the sides first. So if we add up the sides of ABC, we're going to get 3 plus 4 plus 5 is 12. And then if we add up the sides of DEF, we get 14 plus 10 is 24. So 24 and 12 are our perimeters. And as we can probably guess or figure out, the perimeter of triangle ABC, which is 12, is going to be over the perimeter of triangle DEF, which is 24. And our perimeter ratio then makes it 1/2. So our perimeter ratio is also going to be 1/2. And lastly, we're going to talk about our area ratio. So our area ratio, it's important to know the area formula, obviously. So 1/2 base times height. In this triangle, it's going to be 1/2 by 3 by 4. And in this triangle, it's going to be 1/2 by 6 by 8. So we can already see, or maybe you can see, that if we multiply these together, 3 by 4 is 12 times 1/2 equals 6. And 6 times 8 is 48, divided by 2, or times 1/2, is 24. That's going to be 4 times bigger than that. So the way that we can figure this one out is by, so we can say 4, otherwise we'll know, or we will note, that 6 is twice as big as 3, 8 is twice as big as 4, 10 is twice as big as 5, so that's where we come up with that. But then with area, since we're not talking about the lengths anymore, we're talking about, area, like ground that it covers, like 2 dimensionals. We can say that it's this scale factor, but squared, since it's 2 dimensions. So since we're doing 2 dimensions, we'll take the scale factor and square it. This square represents 2 dimensions. It's like going from a line of 1 dimension to something like that with 2 dimensions. If that didn't make sense to you at the end there, don't worry about it. But that's the answers to that top part there. So I'll erase this, and then we'll move on to the actual example that I have pulled up. So very similarly here, we are tasked with finding the similarity ratio, the perimeter ratio, and the area ratio. But this time we aren't given every measurement for the triangles. But like I said, to find the similarity ratio, we're given that DEF is related to ABC. And so to find the similarity ratio, we can use proportions, and we'll use a proportion from DEF, or we'll use a length from DEF, and we'll set that over the corresponding length from ABC, which is going to be 6.5. Maybe y'all know this off the top of your head, but 13 divided by 6.5 is going to be 2. So the similarity ratio is 2. And y'all might guess, based on the last one, of what the perimeter ratio might be. And I would say that you are correct. So since we're adding all these up, and we know that each of these sides is going to be the same scale factor, each one of these sides is going to be the same as this triangle times a scale factor. And we found that scale factor was 2. So if we were to add all the perimeters up, so let's say this is x and this is y, which would mean that this is 2x and this is 2y, right? Perimeter is just adding all the sides together. So perimeter can be 6.5 plus y plus x, and this is going to be 13 plus 2y plus 2x. Actually, we're going to flip those around so that we have it in the same order, or in the same fraction orientation. So as you can see here, we've got this whole thing above this whole thing, and we can factor a 2 out of this one so that we can obtain something that makes it really easy to see. So we have 2 times 6.5 plus x plus y over 6.5 plus x plus y. If we cover up that 2, that fraction we know will equal 1 every time, so we are left with just a 2. And so our perimeter ratio is 2, and I kind of just proved it to you right there why it's going to be 2 every time. So the area ratio, again, just like the last one, we're going to take our scale factors, or not perimeter, or yeah, just our similarity ratio and our scale factor, which is 2, and we are going to we're going to square that because we're working with stuff in the second dimension now. So with that second dimension and the scale factor, our area ratio is going to be 4. And so to fill out the last portion, we'll find the perimeter of triangle ABC. So we know that the perimeter of EDF is 54, right? And we know the scale factor is 2, which can be thought about as like 2 to 1. So if we think about it, we're going to set it up like this because this is our scale factor. Every time, or for each 1 unit or 1 inch in the small triangle, we're going to have 2 in the big triangle. So this upper row is going to be the big triangle, and this lower row is going to be the small triangle. This is going to be the perimeter for the small triangle, and this is the scale factor, like I said, and this is the perimeter for the big triangle. So we'll cross multiply, and we'll get 54 equals 2p, divide both sides by 2, and our perimeter of ABC is equal to 27 inches. And now lastly for our area, very similar method here, except we're going to use our area ratio. So we take our area here, 126, and we are wondering about the corresponding area to ABC. So I'll put an A there to signify the area of ABC. And just like how we did the scale factor, or set it equal to the scale factor, we're going to do the same thing over here. So in area, for each square unit that the small triangle has, we found out that the big triangle is going to have 4 square units. So the area ratio is going to be 4 over 1. So now we'll cross multiply this. We'll end up with 126 equals 4a divide by 4, and we'll end up with 31 and a half. And that's inches squared since it's area and not perimeter. And so here's how we find perimeters and areas based on similarity, perimeter, and area ratios. If we have any questions on this, we'll definitely go over it in class next time we got it. But I'll see you then.